So now we're gonna actually go in a minute, go through a user tutorial. From start to finish, we're gonna implement a workflow running on an HT Condor access point. Often at this point in Condor Week, we give like a 45 minutes to hour-long user tutorial that kind of goes through all the features, all the intro information you could possibly need to start using Condor. We decided not to do that this year. There's multiple copies online. There's some recordings. You can check it out if you want more of like a presentation style introduction to how to use Condor as a user. But what we thought we'd do this time is work through a real workflow, get it running, and talk a little bit through the thought process of what it takes to move from, so I ran this thing on my laptop, to this is how I build a scaled up kind of workflow. So I will, if all goes well, be doing this from a Jupyter notebook, and you all should hopefully be able to follow along. So I'm going to sign in now before I start my slides. So I'll sign in, and then great. If you want to follow along, Andrew is going to write the link on the whiteboard. Yeah, I think that'd be better. So there's a tiny URL that Shomik made for the tutorial we did with this on Monday. So it's tinyurl.com/Jupyter Note. Jupyter spelled Jupyter. So if folks want to, if you're interested in following along and you want to get that open while I go through my intro here, feel free. Okay. So you just saw me go through these steps if you are accessing the notebook, but I'll slides. There we go. You can go either to this full link or to the tiny URL that I just mentioned. Click on the sign in with CI log on. You can use your institutional ID. If your institution isn't listed, you can use OrcID or GitHub to log in. And then this just skipped over for me, but you can pick either the basic or data science notebook to start. And then when I actually get to the demo, I'm going to open a terminal. So just some context for the interface I'm using. Jupyter is kind of running as a window into an access point, and we're going to be using it to submit jobs to a queue, to a schedule that are going to be running on a little execution point also associated with the AP. Okay, so I'll present our use case in a minute, but a little more vocabulary before we do that. When I'm thinking about implementing a workload on HT Condor, I think about these components. I think about the inputs. I think about the outputs. I think about the thing I want to run, the executable, and the environment that surrounds it. That's going to be one job. And so those are all things that I have to account for as I build an HT Condor submit file. So the example we're going to use is from bioinformatics. We're going to use a tool called BWA, and my limited understanding of how it works is you take sequencing data files and you sort of align or compare them to a reference, sort of a completed ground truth-ish set of sequences, and compare like where the data that you got matches up to the authoritative. So that's my software environment needs to include this specific program, BWA. My executable is going to be like needs to include those commands that I want to run, the BWA commands. This is something maybe I've I've downloaded and installed it on my own computer. I've run it a little bit, so I know what those commands are. We'll worry about the arguments in a minute. And our input files, there's going to be that reference, that authoritative thing that we're comparing against, and then the input files, which are going to be in a FASTQ format. And then the output that's produced are these aligned .sam files. So it produces this kind of comparison file in the .sam format. So this is all mental work that I have to do before I actually come to HD Condor and start implementing my workflow. So each of those things I'm going to translate into some aspect of the submit file. So the software is going to be reflected in a software container that I'm using. So that's the container image option here. My commands are going to go into a shell script. So that's shown here. My input files are going to be fetched to the job execution location using transfer input files. And for now, the default behavior in our setup is that any output files that are generated in the job will get transferred back to your home directory automatically. So I don't need to put anything specific in the submit file for that right now. And for now, we're gonna submit one job. So I'm gonna go to my notebook and walk through what this is gonna look like. So I'm gonna open a terminal. I'm gonna shorten my prompt, hopefully correctly. Okay. And I'm gonna run tutorial BWA to download the files. And this should work for all of you as well. And then CD to change into that folder. Spelled correctly. And then I'm also going to open in the file viewer on the left here, the folder that was just downloaded, so I can see the files that I have right here. Okay. And then I'm going to open this readme .ipython notebook, because this is going to walk through the steps that I just described in a little more detail. So first, I'm going to scroll down to this download data to analyze, and you can either hit the little play button or type Shift Enter, maybe even Command Enter to, what do you mean? It's right there. To download the data. Did I already have the data downloaded? Restart the notebook. Sounds great. Okay. Ta-da! There we go. So, oh, thanks, Shomik. So again, you can hit play or Shift and Enter to start downloading the data. I'm doing this first, and then I'll kind of talk through how I'm going to actually set up the workload, because it takes a little time to do the data download. Do you have a question? Sorry, Christina,
is this the basic notebook?
Yes.
Okay.
Basic notebook, and then again, the tutorial command was just tutorial BWA. So download the files, and then you can open them here on the left. And I'm in the README notebook. Okay, so let's sort of explore all those components I just described are now prepped in an organized way in my folder. So I have a data folder with my different data files. I have a software folder with my container image. I have a script, I can find it, bwcontainer.sh. That looks like this, that contains my actual commands. So there I've got my inputs, my software environment, my commands, And so I'm going to fold them all together into, and I can, you can run these lines in the notebook as well to view the data that we've downloaded. So I'm going to put all of this together in a submit file. So the existing submit file in this tutorial is called bwa-container.sub. And right now it looks like this. So there's some blank spaces that we're going to fill in that correspond to, again, those components I just described: inputs, software environment, and the commands we want to run. So I'm going to open this file. It's the right one, to edit it and make those changes. If you're able to follow along, you can do that. I also have what you should be putting in listed underneath in the notebook. And in fact, I'm going to copy the input data because otherwise it's a lot of typing. So in the submit file, I'm going to put in the container image. So this, again, make sure I have my software environment. My executable is going to be this shell script I just looked at. You do a container.sh. And then I need to account for my inputs, which, if all goes well, I'm going to paste in. Nope. It's the wrong link. It's an unfamiliar keyboard. Okay. Nope. Or I'm going to be typing all of this. Do you think I use Control or Command on this keyboard? Oh, that's what I was trying. Foiled by copy paste, man. Oh. Nope. Okay. Well, yep. Oh. Well, everyone gets to watch me type for a minute. Hopefully things are working better for all of you. Coli rel 606, and that's a FASTQ file. Yep, that is you. And then the rest of this. It worked out okay. I don't know why you're trying to open Cortana there, bud. Yeah, that's what I was wondering. Ah, success. Okay. different like hotkeys. All right. There we go. Okay. All right. So a little more complication than expected. There's my edited submit file. Oh, you're right. And I need to transfer my software, my container file. Okay. Save. All right. If I rerun this cell, it should now match sort of the recommended text that's down here. And so I've accounted for all those components. Now I just run Condor submit. That puts my job into the job queue. And then I can check on it using Condor queue. I'm going to demo over here. I can also use Condor watch queue to show a live kind of updating view of how things are running in the queue. So now we'll let this run and come back to it in a minute. Questions? If you have problems, I'm going to ask Rachel, Shomik, or Andrew to kind of like look over your shoulder and see if they can figure out what's going on. But questions for this so far? What I did, why I did it. Everything makes sense. Confusion. So far, so good. Okay. So this has been essentially just again, a translation from here's what I was running, here's all the kind of pieces, here's how I put them into a submit file and execute them using HT Condor. So provided everything has run successfully, so we'll run Condor queue again. Queue is empty, that would indicate the job is finished. And there is in fact a new SAM file. You can see here in my folder. And if I look at some of the error and output files that were created, it does indeed look like everything ran successfully. So this information is coming from a part of the submit file I skipped over, which are these logs, standard output, and standard error files that are capturing data that would have been printed by the commands I was running. The log file captures information from HT Condor about the job. And then we have the resources we requested here. In particular, looking at the log file, this would suggest that my resource requests are pretty close to what they should be. I used most of the disk that I requested. I could maybe use less memory, but a gigabyte per job is also not unreasonable. So I may just leave that the way it is in the submit file. Okay. So because I have done this before, we're going to do an intermediate step now where we prepare for scaling out. So let me pull up the old slides here. In reality, I don't just want to run this one time on one set of input FASTQ files. I want to run it many times on many input files. In this example, we've only downloaded 3, but could easily be 300 or 300,000. And so I'm going to need to account for the fact that my input is going to be different for each job I run and will produce different outputs. And that's what's going to form my entire high throughput workload. And so we're going to see that show up in the submit file where we replace static values with variables. So more on this in a minute. First, as I said, we're going to do a little bit of intermediate cleaning up of what we want to do. Right now, everything that we just did it's only going to ever run that single sample file. The sample information is what shows up here, SR2584863. And it's written into both files we used. And that's not going to be something that we can multiply and use for multiple inputs. So the first thing we're going to do is take our script and modularize it a little bit. So we are going to, instead of having the sample ID written into the script, we're going to set it as a variable. So this requires a little bit of bash knowledge. So whatever scripting language you're using, this is something that's useful to know how to do. This is just what the bash syntax looks like. And then wherever I see this identifier, which is the thing that's going to change, which is what's going to vary, I'm going to replace it with a variable. So with the sample name. Oop. So I'm going to replace it here, where I actually run the files or run the command. And I'm going to replace it in my messages. Okay. So now I have a script that is a little more flexible. Nope, one more. This is why we test things. That is a little more flexible, that can actually be run with different inputs. And that again is shown in this notebook so that you can see what what those changes should look like if that was too fast, went through too fast for you. What this means in the submit file is I'm now expecting that identifier to be an argument to the script. And so in the submit file, I'm going to uncomment arguments and add in the actual identifier that we used before, hopefully. Okay, so like this. Okay, that's phase one of this intermediate, I'm getting ready to scale up process, as I'm sort of modularizing my script and my workflow. The other piece that I'm going to do that most people don't necessarily think of when they're brand new to HT Condor is how I want to organize my life. So we've already done a little bit of this by putting our data in one folder, our logs in another folder, our software in one. But let's say we want our results, this SRA file to or this SAM file to also go into its own folder. So how we're going to do that is we're going to make a folder. So for the results, and then we're going to add this submit file option that's going to essentially copy or move the expected output to that new path inside the folder. So I'm going to add this in. Doesn't matter where too much. And then because I want to be safe, I'm going to run a test with this setup. It's going to run the same code, the same inputs, everything. But now, because I've made some changes, I want to make sure everything is still going to work the way I thought. And the things I want to look for is that my results are produced the way I expect with the right ID, and that they show up in this results folder. So Condor watch queue again, it's running, that's great. So this may be, especially for all you Unix gurus out there, maybe a little bit like, ooh, this is a little pedantic. But for anybody who's working with, I think, less experienced or people who are new to this space, not everybody thinks like mathematician about modularizing their work in this way. And these are really important intermediate steps to reach the point where you can, and here we go. Hopefully our results are here. Scale up really easily. So from here, the amount of work I have to do is relatively small. I'm going to make a list of all the data that I want to analyze. So that's going to be done with this set of shell commands. So I should now have a file called samples.txt. I'm going to create a copy of my existing submit file just to keep things a little more organized. So I'll close these two windows out here. So this command is going to create a file called BWA alignment. And now is where I can simply go through and replace in the submit file the sample ID value with the variable, because I'm setting it through the list of samples that I generated in the previous step. So I now have a list of samples. This list could have, this as 3, again, could have 300, have 300,000. And so in my submit file, if I go in and change my queue statement to generate jobs based on the inputs in this list, and then replace all my references to the changing input value with a variable. We're going to go ahead and add it to the output and log and error files as well. I go from submitting one job to, let's say, 300 relatively easily. And I have a lot of confidence that everything is going to work, that I've tested both the single job setup, the kind of more modularized setup, and now scaling up is going to be straightforward. So that's the full example. Sort of, if I am building up a workflow, these are the steps that I go through, is sort of initial tests with the software environment and basic input files, kind of a more organized version with maybe 1 or 2 inputs, and then the full scale test. So that, I believe, is all. If you go through the slides attached to this presentation, basically what I just said is expressed in slide form of, when you're ready to scale out, these are some of the steps that are useful to think about. What is a job? What are your inputs? How are you going to generate a list of them? How are you going to summarize your results? You generate a bunch of different results. How can you make your code modular in the way that I just did? How do you want to organize things? Running tests. And I skipped over building software environments. There's a little more information in the notebook if you want to go back to that, or any of the facilitators are happy to chat about it. And we also, in this more simplified example, didn't do anything super complex with data movement. With larger files, you might be using, some other external data source or something like the Open Science Data Federation to move your data around. Similarly, multi-step workloads. These are all pieces that you could then add on to or include in this sort of basic kind of example. So with that, I will take questions, thoughts, confusions. Hopefully everything is crystal clear.